In this video, we're going to be looking in detail about ionic compounds, which are compounds that form when two ions, one with a positive charge and one with a negative charge, come together in order to form a compound. In the previous video where we looked at Bohr diagrams, we talked about how metals form cations because it's easier for a metal to lose electrons than gain electrons. For example, with sodium, we know that sodium only has one valence electron, which means to gain a full valence shell, it's easier for it to lose one electron than it is to gain 7. Conversely, with nonmetals, we know that they form anions, like chlorine. We know that chlorine has 7 valence electrons, which means it's much easier for it to gain 1 electron than it is for it to lose 7. And because chlorine gains 1 electron, that's what gives it the negative charge. And when a cation and an anion combine together, they give you what is called an ionic compound, which balances out the charge. So in this video, we're going to look at how to recognize and how to name ionic compounds where the cation comes from a metal and the anion comes from a nonmetal. These are the simplest forms of ionic compounds. So the first things that we need to do when naming the compound NaCl is to find out what the names of the metal and the nonmetal are, so we can go to our periodic table and look for chemical symbols Na and Cl. We see over here on the metal side that Na has the name sodium, and if we go to the nonmetal side, we see that Cl has the name chlorine. So let's go ahead and write those in here for future reference. And with the metal name, this is actually the first part of the compound's name. We can write the name of the metal in without changing anything, but we're not going to write the nonmetal's name in because we need to make a slight modification to indicate that it is an anion. So we need to remove the suffix, the last few letters of the nonmetal's name, and we need to replace it with a different suffix. So the suffix of chlorine is usually the last syllable of the word. So if we cross out INE, and we can write in the name of the nonmetal without the suffix here, and we're going to replace it with the suffix IDE, pronounced Ide. So when we write in this suffix, this would be pronounced chloride. And the reason for indicating that this suffix is here is that this suffix is used to tell us that this nonmetal is an anion and therefore that it has charge. So following these 3 steps, we can see that the name of this compound is sodium, our metal cation, chloride, our nonmetal anion. But what about going the other way? What about if we're given the name of this compound and we want to find out what the chemical formula of it is here? Now, most of the time we won't be given a convenient structural diagram like this. This is just for visualization. So let's say that we are given the name potassium oxide. So the first thing that we need to do is that we need to find the element symbols to know which element symbol represents potassium and which element symbol represents oxygen. So if we go to our periodic table, we see that potassium has the rather unhelpful symbol of K. That's just one that you'll need to remember. And then oxygen, rather intuitively, is given the chemical symbol O. So let's go back to our handout and write these here. So the symbol for potassium is K, and the symbol for oxygen is O. Now the next thing that we need to do, this will involve going back to our periodic table, is we need to find out the charges of the metal and the nonmetal. So in this case, we're dealing with metals that only have one charge. Metals that have multiple charges are a little bit more complicated. So if we go back to our periodic table, let's look for the charges of potassium and oxygen. So we're on oxygen here, and we can see that oxygen has a -2 charge, and that makes sense because we know that oxygen has 6 valence electrons based on the pattern, which means that it's going to gain 2 electrons, and therefore that gives it a -2 charge. If we go to potassium, we see that its charge is +1, and because potassium is an alkali metal, we know that it only has 1 valence electron, and if it loses 1 electron, that will give it a +1 charge. So the charge of the metal is +1, and the charge of the nonmetal is -2. Now, in an ionic compound, the way that we decide how many metal ions and how many non-metal ions we have is that the overall charge of each ionic compound is always going to be 0, which means that the total positive charge and the total negative charge has to cancel each other out. Therefore, what we need to find is the lowest common multiple that the two charges, the charges of the metal ion and the non-metal ion have. Now, between 1 and 2, this is easy. The lowest common multiple for 1 and 2 is 2. So we need to multiply each number by this lowest common multiple in order to get to 2. So we know that +1 times 2 is +2, and we know that -2 times 1 is -2, and if we go +2 minus 2, we get 0. So what I just did here is we actually figured out how many of each ion we need. So because the lowest common multiple between 1 and 2 is 2, that's the number we need to get to. And in order to get to a total charge of +2, we need 2 potassium ions, but because -2 is already 2, we just need to multiply this by 1, which means that we only need 1 oxygen ion. So because we have 2 potassium ions, that means +1 times 2 is +2, and if we add this to the charge of oxygen, -2, we get 0, and our charges balance out. Therefore, the chemical formula for potassium oxide is K2O. So before we move on to the next type of ionic compound, take a look at the compounds in this table here and see if you can write the formula based on the name, and use your periodic table to write the name of the compound based on the formula that you're given here.